when we solve our two quadratics, guys, there are multiple ways we can do it. We're going to talk about two of the ways. All right, what's one of the ways we can get through solving quadratic? All right, we can do the factoring, the six-step method here, your AC method, your factor by grouping, however you want to call it, the X method. Or what's another way? Quadratic formula. We're going to do both ways here. So first we're going to go through a factor, then we're going to go through and do the quadratic formula. All right, so let's look to see first about factoring. All right, so my A value is not a 1. So what do I need to do to factor this? What's the first thing? Multiply your A by C. So your A value is 3. C value is -8. So A times C is -24. So I'm going to look for two numbers that multiply to be -24, but add to be -10. All right? Two numbers that do that are what? -12 and +2. All right, so now what the next step is, guys, I'm going to rewrite my function, but instead of using -10x, what am I going to replace it with? -12x and 2x. Good. So I'm going to have 3x squared minus 12x plus 2x minus 8. It is magical. I know it is. All right, so what's the next step? Group it. All right, so I'm going to group my first two. Group my second two. Now, what can I factor out of that first group? 3x, good. What am I left with? X minus 4. What can I take out of my second group? 2. I'm left with x minus 4. Like we've done before, guys, the values inside your parentheses should be the same thing. If they're not, you did something wrong, right, Will? Okay. All right, so guys, your final factoring is 3x plus 2 times x minus 4. Now, are we done solving? No. What do I do with each of these? Set each piece equal to 0 and solve. All right, so 3x plus 2 equals 0, and x minus 4 equals 0. I set each piece equal to 0, and I solve. So here, what am I going to get? -2/3, so we get x equals -2/3. And I'm going to get x equals 4. So, guys, that's going about using the factoring method. Now, that way only works when your quadratic is factorable. If it's not factorable, then you can't factor it. All right, so there's one way, though, that will always work, whether it's factorable or not. That is the quadratic formula. So, refresh thy memory. What is it? -b. Squared, b squared, all over 2a. So, quadratic formula. You got to know it. If you don't know, now you know. All right, very good. All right, so guys, I got to use my a, b, and c value. So, going back to my original function, what's my a value? 3. B value is -10. C value is -8. All right, so plug everything in. Opposite B, negative B is going to look like what? +10. So it's minus a -10, so it's +10. Plus or minus, square root. What do I have underneath, guys? 10 squared, which is 100. Minus 4 times -8. All that over 2 times a, which is 2 times 3, which will give me 6. All right, now, guys, from here, it's just a matter of simplifying. So on the outside, I've got +10 plus or minus square root. So I've got 100. What's -4 times 3? -12. -12 times -8. +96. All over 6. Now, underneath my square root, what do I have? 196. What's the square root of 196? 14. So this is 10 plus or minus 14 over 6. Now, how many solutions does this represent? 2. One of those is 10 plus 14. So 10 plus 14 gives me 24 divided by 6 is 4. My other one, guys, is 10 minus 14, which is -4. -4 divided by 6 reduces to -2/3. So, guys, if you notice, It doesn't matter if you use factoring, if it's factorable, or if you use quadratic formula, because that'll work every single time.
I did the negative -4 times 3.
Today, what we are doing, guys, we're going to solve quadratic inequalities. Now, the part of the process in going through and solving a quadratic inequality is going to be us going through and solving the quadratic. Now, you can use factoring. You can use quadratic formula. If you wanted to go through and try to complete the square, have at it. That's not my recommendation, but you could if you wanted to. But I would recommend. All right, so what we're going to do, guys, is we're going to take these quadratics and solve them. Now, if you notice here, we've got an awesome line. Yes. We are going to be plotting on a number line. You guys remember back in like kindergarten when you guys plotted numbers on number lines and all that kind of stuff? All right, yes, alligators, chomp chomp. Shading, yes, all that wonderful stuff. All right, so first, guys, go ahead and get this problem down. So, guys, looking at my quadratic here, I've got x squared is less than or equal to 4x plus 12. All right, now, first thing I'm going to do is I'm just going to bring that down here and rewrite it. So x squared is less than or equal to 4x plus 12. Now, if I'm going to solve this as a quadratic, what's the first thing I need to do?
Make it non-quadratic.
Right. Move my 4x over, move my 12 over, get it in standard form. All right, so to move the 4x over, what do I need to do? Subtract it. To move the 12 over, what do I need to do? Subtract it. All right, so then I'm left with less than or equal to 0. Now, once I get it to this point when it's a quadratic, now I can go ahead and just treat it as an equation when I solve it. Now, for this right here, you can factor it. You can do quadratic formula. You can complete the square, anything like that. Now, this one is probably most easiest factorable. All right, so what are two numbers that multiply to be -12, but add to be -4? -6 and +2. So right there, guys, -6 times 2 is -12. When you add those, you get a -4. So those are my two values. So when I'm solving that now, how do I solve for my two x values? You set them equal to 0. All right, so if I set x minus 6 equal to 0 and x plus 2 equal to 0, what do I get? 6 and -2. Now, those two values are going to be what I'm going to call my critical values. All right, if I was solving a quadratic equation, those would be my solutions. All right, however, because this is an inequality, I'm going to have a set of solutions. All right, so these are the values that I'm going to plot on my number line. All right, so I'm going to start with the 0 in the middle. All right, where would 6 be in relation to the 0? To the right, so somewhere out here. Where would -2 be? To the left. So to the left, so somewhere right over here. There's -2. Now, because I have an inequality that's less than or equal to, are these going to be open or closed circles? Those are going to be closed circles. So I'm going to put a closed circle here at -2. I'm going to put a closed circle here at +6. Again, because of that equal to underneath it. All right? So that's the first part. So those are my critical values. Now I got to test some points to see where I'm shading. All right, so let's test a point to the left of -2. What's the value to the left of -2? -3. Or you can do -5, you can do -10, you can do -1 million if you wanted to. I don't recommend it, but you could. So let's just pick a point. So let's say -3. Now, you can plug it into your first equation. You can plug it in here. Or you can plug it in the second one. Which one do you want to plug it into? Second one. All right, so let's plug it in -3. So if I take it, I plug in a -3. So -3 squared -4 times -3 minus 12. Is that going to give me a value less than or equal to 0? So let's see. What's -3 squared? 9. -4 times -3 plus 12. That's what, 21? 21 minus 12 is going to give me 9. Is 9 less than or equal to 0? No, it is not. Not a true statement, which means I'm not going to shade in that area. All right, so let's pick another point, another test point. What's the point between -2 and 6? 0. That's the easiest one, guys. Always plug that one in if you can. So if I plug it in, I got 0 squared minus 4 times 0 minus 12. What do I get when I simplify? Is -12 less than or equal to 0? Yes, it is. -12 is way out here, guys. There's 0. -12 is less than or equal to 0. So I'm going to shade there. All right. Now, typically, on average, if you shade on the outside here, you're going to shade on the outside over here. Or you're just going to shade in the middle. That's not always the case, but typically that's going to be the case. All right. So just to make sure, let's plug in another point that's past 6. 7. All right. What else could I plug in? 8, 9, 10, anything like that. Let's plug in 10, just for kicks and giggles. All right, so 10 squared minus 4 times 10 minus 12. So it's 100 minus 40, which is 60. 60 minus 12 is 48. Is 48 less than or equal to 0? No, it is not. So that is not a true statement either, which means I'm not going to shade there. So my final solution is to write this as a set. So always start from the left and go to my right. What's my farthest left value I want to include? -2. Bracket or parenthesis? Bracket. Up to, what's my farthest right y value? +6. So that is my final answer. So you guys try number 2, por favor. Now, guys, we got my inequality. What's the first thing I need to do, though? Before I do that, you got to get in standard form. All right, so I got to move my 5x over. So how do I move my 5x over? Subtract 5x. How do I move the 3 over? Subtract 3. So I'm left with greater than 0. Now, before I go any further, this is just greater than. It's not greater than or equal to. So when I mark my critical values, am I going to put an open circle or closed circle? Open. So once again, this right here means I'm going to have open circles. All right, not closed. Closed would mean greater than or equal to. But it's just greater than, so I just want open circles. Now, next thing, now that it's in a quadratic form, if it can factor, you can factor it. If it can't or you don't want to check, what else could you use? Quadratic formula. Now, because we factored that last one, I want to do quadratic formula here. If you went ahead and factored it, because this one is factorable, that's fine. You should still get the same answer. All right, so let's just go through and do quadratic formula real quick, just to use an example using that. All right, so what's my b value? It's -5, so it's opposite -5, so +5 plus or minus square root. B squared is going to be 25 minus 4 times, what's my A? 2 times C? -3. All over 2 times A, which is 2 times 2, so a 4. All right, so now we'll go through and just simplify. Now, underneath my square root, all right, I'm going to have 25. What's -4 times 2? -8. -8 times -3. +24. 25 plus 24 gives me 49. Square root of 49? 7. So it's 5 plus or minus 7 over 4. Now, this represents how many solutions? 2. Dos. All right, so one of them is 5 plus 7, which is 12. 12 divided by 4 is 3. 5 minus 7, which is -2 over 4 is -1/2. Now, if you factored that, you should have gotten the exact same 2 values. All right? If you did not get those same 2 values, then you factored incorrectly. All right? So, guys, now that I know my 2 critical values, now I can plot those on my graph, on my number line. So, we got a 0. Where is 3 in relation to 0? To the right, to the right. All right. Where is -1/2? To the left, all right? So negative 1/2 is just going to be somewhere out. It's a negative 1/2. Now, we said because this is just greater than, are these open or closed circles? Open circles right there. So open circle there, open circle there. Those are my critical values. All right, now to figure out where I'm shading, so let's go to the right underneath here. To figure out where I'm shading, let's plug in some test points. So what is a test point to the left of negative 1/2? Negative 1. Let's plug in negative 1. So 2 times negative 1 squared minus 5 times negative 1 minus 3. We're checking to see if that is greater than 0. Now, negative 1 squared, 1. 1 times 2 is 2. What do we get here? Positive 5, and we get minus 3. So that's 7 minus 3, which is 4. Is 4 greater than 0? Yes, it is. You bet your bottom dollar. So, because negative 1 worked, I'm going to shade where negative 1 is located, which is that. Bless you. Now,
So like all the numbers outside of one.
now let's pick something in between. 0. That'd be the easiest one. So it's 2 times 0 squared minus 5 times 0 minus 3. Again, plug in 0 back to main equality, so we get 0, 0, we get negative 3. It's greater than 0. Is that true or false?
False.
False. Have to show at least a little something. All right, so nothing works inside because 0 didn't work, so let's try something after 3. 4. You want to try 10? That's fine. So let's plug in a 4. So 2 times 4 squared. 5 times 4. So 4 squared times 2. 32. Minus 20. Minus 3. So that's 12. 12 minus 3 is 9 greater than 0? Yes, it is. So that means I shade past 3. Now, the key here, guys, is to write my solution set correctly. Now, you always start from the left and you work your way to the right. What is my farthest left x value that's shaded? This is going to go all the way out to negative infinity. So we'll start at my left. So I'm going to go from negative infinity up to, where does it stop? Negative 1/2. Since it's open, it's going to be bracket or parenthesis? Parenthesis. And then where does it pick back up? At 3 with a parenthesis. And where does it stop? Positive infinity. There you go.
Oh, you don't use brackets?
No, because they're open circles. Infinity always, always, always uses parenthesis. Cool. Last one.
So
Y'all try this one for me real quick.
it's just
So, first thing, I need to get everything on one side, and my recommendation is to keep your A term positive. So, right now my A is 4, 4x squared, so let's keep it on that side. So what do I need to move? Let's move that 5x over. How do I move it over? Subtract it. So, we'll go 4x squared. Now, make sure that's my B term. That 5 represents my B term. So, when I move that over, I'm going to put that in the B term slot. So, minus 5x, minus 9, and then we've got less than 0. Now, once again, because that's just less than, it's not less than or equal to, it's going to be open or closed circles. Open circles. All right, so let's go through. Now, since I did quadratic formula before, we'll do factoring here because this one is factorable. Oh, it is. Oh, that's interesting. Fancy schmancy. So, factoring, guys, your AC method, your X method, your factor by grouping, however you want to call it. All right, so I'm going to multiply A times C. 4 times negative 9 is negative 36. So I'm going to look for two numbers that multiply to be negative 36, but add to be negative 5. Negative 9 and positive 5. Very good, Malik. So,
Wait.
You can't just look at one number and multiply it.
well, it's not, because it's not a 1 out front. Yeah, if there's a 1 out front, then yes, that's exactly what you do. But because it's not, you gotta do A times C and all that
Well, I think I'm
stuff.
wrong.
All right? So yeah, it's negative 9 and 4. Yeah, you're right. Negative 9 and positive 4. So, guys, I'm going to rewrite negative 5x using negative 9x and positive 4x. All right, so when I rewrite that, so we're going to have 4x squared minus 9x plus 4x minus 9. Now, if you want to put the 4x first and then the negative 9x, that's wonderful. You can do that. That works. All right, so I just kept it like that. Now, what's the next step going to be?
Group 'em.
Very good. Group them. All right, what can I take out of that first group?
X.
X. So I'm left with 4x minus 9. Can I take anything out of that second one?
No.
No. But what you can always take out is a 1. All right, so we've got that right there. So what's my final factor going to look like? X plus 1 times 4x minus 9. All right, so we're going to set both of those equal to 0 and solve. Yep.
What if it's not the same? What if the S
Then you did something wrong up top when you were factoring. They should always, inside of parentheses, should always be exactly the same. Yeah, so if not, then you got to go back and check some factoring. All right, so if I set x plus 1 equal to 0 and solve, what do I get?
Minus 1.
You get a negative 1. Negative 1, there we go. And if I set 4x minus 9 equal to 0, what do I get? You get 9/4. Now, guys, for graphing purposes, what is 9 over 4? 2.25, 2 1/4. All right, 2 1/4. So let's go ahead and plot these critical values on my number line. So I got my 0 right here in the middle. All right, now, negative 1 is where in relation to 0? To the left. Take it back, Gil. No. Too hot, sister. All right, now. There you thank you, Drew. All right, so guys, where is 9/4 on my graph in relation to 0? To the right, to the right, to the right. All right, so we're going to call it 9 over 4. Just make sure, guys, we'll put parentheses underneath. It's 2.25. That's what it represents. All right, so 9/4. Now we said because it's just less than, not less than or equal to, are these open or closed circles? Open. Opa. All right, now, how do I figure out where I'm shading? Plug it in, pick some test points. So first, let's pick something to the left of negative 1, like negative 2. Super. So if I plug in a negative 2, we've got 4 times negative 2 squared minus 5 times negative 2 minus 9. All right, when we simplify that, what's that going to be? 16 plus 10. That's 26. 26 minus 9. Is that 17? Is 17 less than 0? No, it is not. Next, plug in a middle point. 0. So if I plug in a 0, now if I plug in a 0, what do I get? Is negative 9 less than 0? Yes, it is. So I'm going to shade there. If I plug in a value to the right of 9/4 for 2.25, what can I plug in?
4.
Like 4? If I plug in a 4, so I've got 4 times 4 squared minus 5 times 4 minus 9. What is that? That's 16, and 16 times 4? 64. Minus 20 minus 9. What do you get, guys? 35? Guys, it's 35 less than 0. No, it is not. So, 35 less than 0. Nope. So, I don't shade there. So, my final answer, guys, is going to be writing this in set notation. What's my farthest left x value? Negative 1. Bracket or parenthesis. Parentheses. So, from negative 1 up to 9/4. So, that is your final answer.